three different things today. Finding function values when we're given a piecewise defined function. We're looking at finding function values when we're given a graph. And then lastly, we're looking at finding domain and range when we're given a graph. Those are the three things we're looking at today. The first two things, usually we go through pretty quick. And the last one is the one we have a little bit of trouble with. All right, what you're looking at up here is called a piecewise defined function. And it should make sense because I've got different pieces that make up the function. And what this says is I've got three different functions, but over here on the right it tells me when to use each specific function. Now, the negative 5x squared I only use when it's x less than negative 6. So only from negative 6 out to negative infinity, that's when I use the top one. The middle one I use when I'm dealing with x values between negative 6 and 12. And then my last one I use when I'm dealing with x values bigger than 12. So I've got three different functions inside of this function, and I've got three different times when I use each one. So that's what we're doing here. Now, they want me to find some function values out of this. They want me to find f of negative 5, and they also want me to find f of 12. So what I have to do is I have to look at the x value they give me. I have to look at the domains on the right and then decide which function I want to plug it into, the top, the middle, or the bottom. So if I'm going to find f of negative 5, which one of those functions do I want to plug into, top, middle, or bottom? Middle. Why the middle? Because negative 5 is between negative 6 and 12.
So you only look at the right side?
The right side tells me which one of these three to use. So I take my number I'm plugging in, figure out which one of these it fits in, and then plug it into the function that goes with it.
How do you know negative 5 then? It gives you that.
How do I know this? Yeah, the problem tells me to find this and find this.
Oh.
Is what it does.
Okay.
So what I'm going to do is I'm going to take negative 5. I come over here. I see that negative 5 is in between here. And then I want to plug negative 5 into this function. So we're going to go negative 5 squared plus negative 5 plus 1. So this ends up being 25 minus 5 plus 1. 25 minus 5 is 20. And 20 plus 1 gives me 21. So that means f of negative 5 is 21. All right, then I want to find f of 12. So I come over here and I need to figure out where does 12 fit? Top, middle, or bottom?
Middle.
Middle. Why does it fit in the middle and not the bottom?
It's equal to 12.
Because I got the equal to right here in the middle. So that means I've got to plug 12 into the same function I did with negative 5. So I'm going to do 12 squared plus 12 plus 1. So 12 squared gives me 144. 144 plus 12 is 156, and 156 plus 1 gives me 157. So that means f of 12 is 157.
Yeah.
Question?
It
She
looks
said it was
it's-
easier than it looks.
Yeah, it looks complicated, and that's part of the problem with these piecewise functions is even in calculus, they'll look at these things and they'll get scared of them, and they'll just skip over them. But yeah, there's really not much going on. As long as you know what's going on and you know where to look, then it's not that bad. All right, so that's the first thing, and I really think we only need one example. Is everybody good with finding function values when you have a piecewise function? Everybody know what to do? Okay? All right, now let's look at finding function values when they give me a graph. All right, this is on page 19. We're looking at number 1. And what they have is they have a graph, and then they want me to find these three function values using the graph. Now, what is it that we find whenever we're looking for a function value? What type of value is it we're looking for? Well, the x is what I'm plugging in, right? So what is it that I get out? A y value, the range. So that's what I need to keep in mind is whenever I'm looking for a function value, I should be getting a y value as an answer. So keep that in mind. So here's how these work. If I want to find g of 6, what I need to do is go find the x value of 6 and then find the y value that corresponds with that x value. So the first thing let's do is let's figure out where 6 belongs on this x-axis. By looking at it, how much is each square worth?
4.
Looks like each square is worth 4, because from here to here is 8, so if I take that in half, it's worth 4. So where would 6 be?
In the middle of 8 and then the first line.
Alright, so that means 6 is going to be right there. So to get the y value that goes along with it, what I want to do is I want to go up until I touch my graph, and then once I touch my graph, I want to go over, and that'll tell me what y value goes with that x value. So by looking at it, what would be an approximation of that y value? Looks like 38. So we're going to say g of 6 is equal to 38. Okay, now we want to find 12. Where is 12 on this x-axis?
In between 8 and 16.
8 and 16, so 12 is going to be right there. So we're going to go up, we're going to touch, and we're going to go over. Now, don't waste your time on trying to get the exact number. Just something close is going to be fine with me. So what can we say this one is?
2.
32. So we're going to say this is 32. Then I want to find g of 19. Well, this mark right here, what would that mark be? That would be 20. That one would be 18, so halfway in between those two is where 19 is going to be. So 19 is going to be right there. We're going to go up, we're going to touch, and we're going to go over. So we're going to call that one what?
28.
28. So that's how you find function values when you're using a graph. How do we feel about that?
Good.
Good? Okay. All right, now let's get into the little bit more difficult stuff. I don't want help.
So those were the answers?
Those are my answers.
Oh, so you didn't have to do anything with that equation?
No.
Oh.
If you plug these values into the equation, you should get something close to this.
Oh.
So if I take 6 and I plug it in here, I really can't get the square root of 6. Okay? But if I use my calculator, took the square root of 6 times -5 plus 50, it should give me something close to 38.
Okay. That's just
Yeah, we're just using the graph to get an approximation is what we're doing. All right. All right, now we want to look at finding domain and range from a graph. Again, remind me what domain is. X values and range is the Y value. Okay, here's what it is when we're trying to find domain and range from a graph. When we're finding domain, what we're looking for is what X values have a corresponding Y value. Okay, what X values can I find a Y value for? And then for the range, it's the reverse. Which Y values have a corresponding X value? Okay. So here's how I like to find the domain. I like to go to my x-axis, and then I like to draw just random vertical lines. And if those vertical lines touch the graph, then that means that x value is in the domain. Okay? If I draw a vertical line on an x value that doesn't touch the graph, then that means it's not in the domain. Okay? So if I can get an x value to intersect, it's in the domain. If I get an x value that doesn't intercept, then it's not in the domain. Okay? So let's think about that. Remember, these arrows tell me it keeps going to the left and it keeps going up. That tells me it keeps going to the right and it keeps going up.
Yeah.
So my question is, when I draw vertical lines on my x values left and right, are there any x values that will not touch my graph? No. So since all of my x values, I can draw vertical lines to intercept the graph, what does that tell me about my domain? All real numbers. So that means my domain is negative infinity to infinity. And keep in mind, whenever I'm finding domain, I want to be looking at the x-axis. Whenever I find range, I want to be looking at the y-axis. Now, when I was finding domain, I drew a vertical line. If I'm finding range, what do I want to draw? I want to draw a horizontal line and ask the same thing. When I draw a horizontal line, does it touch my graph? If the answer is yes, then that means it's part of my range. If the answer is no, it's not part of my range. So, what do you think? Are all my y values part of the range? No. Why not? Because if I draw something down here, is it ever going to touch my graph? No, it's never going to intersect. Okay? So, what we want to do when we're doing range is we want to start with the smallest number and then move to the biggest number. So, what's the smallest number? And just give me close. You don't have to get exact. What's the smallest number that if I drew a horizontal line would touch my graph? 2. So, we're going to say my range is from 2, and then how high does it go? It goes to infinity. So that means my range would be from 2 to infinity. Bless you. So what that's saying is, any x value I plug in here better give me an answer that is between what and what?
2 and
Between 2 and infinity. If I'm getting an answer that's not between 2 and infinity, I did something wrong. So that's what we're figuring out with the range. The range tells me what kind of answers am I going to get. The domain tells me what is it I'm allowed to plug in. Let's try another one. So let's look at this one. I got a little half circle here. I've got a closed dot over here. It goes over, and then I've got an open dot on the right. So somebody raise your hand and remind me, what is it that we're looking for when we're finding domain? We're looking for the x values that have what? A corresponding y value is what we're looking for. Okay? And we do that by drawing vertical lines on the x-axis, and if it intersects, that's part of the domain. If it doesn't intersect, it's not part of the domain. So can somebody give me what they think the domain would be on this problem?
-2
-2.
to
-2 to 6. All right. What do you want to put on the -2?
bracket. Bracket.
A bracket. And what do you want to put on the 6? A parentheses. Everybody agree with that? That is correct. Everybody understand why there's a bracket here? There's a bracket because I've got a closed circle, and there's a parenthesis on the 6 because I have an open circle. So that's the domain. Okay? Now, somebody else take a shot at the range. 0 to 4. 0 to 4 would be my range. Now, what do you want to put on the 0? It's going to be a bracket. What about the 4?
Bracket.
It's also a bracket. And some of you may be thinking, well, like this, there's an open circle here and there's a closed circle there. A closed circle always trumps an open circle. So if you've got a closed circle anywhere, then that means it's going to be a bracket. The closed circle always trumps an open circle. Okay, and a key when you're finding domain is you always start on the left and then move right. When you're finding range, what do we want to do?
Up and
Start at the bottom and move up. It's always domain is left to right, range is bottom up. That helps when you're finding domain and range. Try another one. Okay, this one has a couple different pieces to it. So look at it. If somebody feels comfortable, you should tell me what the domain would be, and then we'll let somebody else tell me what the range would be. Domain, -4 to infinity. Is that what you're telling me? So you're saying the domain would be from -4 to infinity. All right, how are you going to write that? -4, infinity. Do you want a parenthesis or a bracket on -4? I want a parenthesis, and that would also be parenthesis. Does anybody agree? There's a problem with that. What's the problem with it? It's close. What do you got? No, it doesn't extend left. It keeps going out here to the right. That's going that direction. What? There's a hole at 2. If you look, is there a y value for 2, for the x value of 2? No. So that means when I write it, I'm going to have one section and then another section. So I need to go from -4 to 2, parentheses on both of those, and then to infinity. Everybody with me there?
When there's 2 lines, does there need to be like 2 sets of interval notations?
It doesn't have to be, but it's good to look at each one and get a set, and then sometimes you can combine. All right, what about the range? Remember, on the range, we want to work from where to where?
bottom up.
Bottom up. Okay, so what's my bottom number?
Infinity.
Negative infinity. Okay, and as I work up, where do I run into my first problem?
-1.
-1. And it looks like -2, actually. And I think
Oh.
each one's worth 2, right? What do I put on -2? Parentheses. All right, then from there, as I work up, where do I start to hit the graph again? 6. Does it go past 6?
No.
No, it's just at 6, right? So if I'm going to put just 6, I'm going to put 6 with a bracket on both sides of it.
So
Right.
you don't put the 2 again?
I don't put the 2 again because between -2 and 6, if I draw a horizontal line, I can't touch it. So if I can't touch it, I can't use it. I can only use the ones I can touch. Another question? Because I can use 6, which means it's got to be a bracket, and it doesn't go anywhere. It's only at 6. So that means there's only going to be one number in it.
So it's just that point.
It's just that y value. That's correct. So when I plug stuff into this problem, I should only get answers between negative infinity and -2, and then 6. That's it. Those are the only possible solutions I can get when I plug in an x value. Let's try another one. All right, on this one, I've got a closed dot down here. I've got an open dot here, and then I've got an arrow up there. So look at it for a second, and then we'll talk about the domain and range of it. All right, Chris, what's a starting point on the domain as we go left to right? Where would I start? Where's the x value on the left? And if I draw a vertical line through it, it'll touch the graph. Because there's some x values on the left that won't touch. Negative. Actually, I come over here. If I draw a vertical line right here, I'm going to touch. So think about the x-axis and drawing vertical lines. So over here, if I draw a vertical line right here, that's the first place I'm going to touch on the left, would be -8. And since there is a closed dot, I'm going to have a bracket. Okay, then Emily, from there, as I move to the left, where do I run into my first problem? -4. Because at -4, I've got a hole. So what do I want to put on -4?
Parentheses.
Parentheses. Okay, and then I pick up again at -4. And I go from -4 and I keep going to the left. Do I run into any more problems?
No.
No, because it's solid here, and then it continues on that way, which means all of my x values over here will eventually intersect with my graph. So that means we're going to infinity. So you always start on the left. Where do I first, if I draw a vertical line, where do I first touch my graph? And then I move to the right and find my problems. On this one, the only problem was at -4. Now we want to do the range. So we're going to start on the bottom and move up. So Laura, where do I start on the bottom? Where's the first place I pick up my graph? All right, what'd you say? -10. You want a bracket or parenthesis on -10? A bracket. Okay, then from -10, as I move up, do I run into any problems? Are there any holes or gaps as I move up? 4? Okay, what do you guys think about 4? There is a hole there at 4.
But there's like more of it.
But there's a spot over here, and what did we say a while ago?
Closed circles.
A closed circle trumps an open circle. So since there's a closed circle over here, that trumps the open circle. So that means there is no problem at 4. So as I keep going up, are there any more problems?
No.
No. So I'm going to go from -10 to infinity. And that would be my range. Feel a little bit better about it? Good. Just remember, domain, what's my furthest left value that I can start with on the x, and then move to the right and find your problem spots. On the range, you start at the bottom and move up. Okay? So we did 3 things today. We found function values from a graph. We found function values with a piecewise defined function. And then we found domain and range of a graph. So those are the 3 things we worked on. All right, I've got 9 problems for you.